Well, this is different. We're going to do a repair here and now in front of you all of a very broken set, which, and I'm echoing because I can hear myself through the monitor. So what's happened here is one of our viewers very, very kindly said to me that he had found a Cybernet Beta 2000 in a box in a skip, and I think that's what the story was, and he took it home and it works a treat. And I think that was in response to the Cybernet Beta 2000 video that I did a few weeks ago, which was one of our customers' repairs. So he said there was another one, but it just shorts out and that. So he had a look at it. He couldn't get anywhere, and he said, "Would I like it as a freebie?" So I said, "Absolutely. I'd be happy to reimburse his post." He says, "No, not at all. I don't mind at all." So very, very kind of him, and that's the first time that's happened. When I was a teenager, you know, and I was interested in electronics, you got people at school whose dad would cast off a worn-out old television with a useless CRT, and although it was useful in electronics fault finding, you never had a usable picture because the CRT was no good. But anyway, there we go. I digress. So as you probably know, we're just going to digress even further. As you probably know, our main business here is in traditional church pipe organ restoration, and I work as a professional church organist, and we do that I do that at 6 churches, shall we say full time, until this lockdown happened, and then I'm available to 40-something other churches. Well, yesterday I got an email from one of the churches I do play at, and they said, would we like to tune the organ instead of the current firm, you see. So I said, yeah. So we've got that to do this afternoon, so I need to be off. It's Sunday. Of course, there's no church services because of this lockdown, so after how many years as a church organist, you know, it's like really weird not going for 2 or 3 services. Anyway, luckily, as you all also know, that I have a full-size pipe organ here at Tango Towers. So I have redacted the address because I don't want that many letter bombs from people who want me to do things that are illegal, and it isn't going to happen. So we'll open this box. And is it a Cybernet Beta 2000, or have I got the wrong end of this stick? Ooh. Yeah, it's a Cybernet Beta 2000. Thank you very much, Kevin. See. So it's had plenty of use. We can see that around the volume control it's worn, and that's always a good sign. There's nothing worse than a set that is so immaculate that when you get it out of the box it doesn't work because, or it's really, really rubbish and set up wrongly, because the original owner tried it for about 2 days, was so disgusted with it, he put it back in the box. Now these, I recall these are supposed to be black screws, and I think the person who's kindly given it to me has put those in, which is fantastic, and they are excellent screws for unit ends. But if we get this working, we'll put black screws in, and we'll keep the shiny screws for unit ends and audio lines and other sets that we need shiny screws for. So if this is blowing fuses, which I think he said so let's have a look. has it been? Has it had loads of work? No, it hasn't. No. What I like about Cybernet radios, apart from I've got to unsolder the speaker, is that I always think that when a manufacturer puts their own name on Cybernet, doing Cybernet radios instead of all the other millions of brands that they did, I always think they're going to be the better sets when it's their own. So that's always my take on that, and I've not been disappointed on the Cybernets, and it's such a shame that Kyocera bought them up and turned them into a solar panel factory instead. All those years of CB know-how gone. Okay, so we've got a situation where he says there's a short across the power line. So put the meter on, put the probes together to prove the continuity is working. There's the power connector, and it's dead short, just as he says. So I'll now dig out the service manual, and I'm competing with Radio BBC World Service, because on our background music system it's programmed to play different radio stations on the hour throughout the day, and it varies between Radio 4, BBC Radio 4 that is, Radio Lincolnshire and BBC World Service, so I kind of get a rounded outlook of the news, and I'm somebody who doesn't do television, so this is how I get the news. But it would just compete with me when I'm doing a video. I turned down the background music and blow me, I forgot to switch off the radio tuners. So I've managed to find the circuit diagram. It was still on the clipboard from a few weeks ago, so it'll make my job a bit easier. Now, those of you who are into CB radio repairs, and it doesn't matter what country you're in with this bit of the discussion, it's blatantly obvious to me what's going to be at fault, and that will be the polarity protection diode will be short circuit. If it isn't, then it'll be the audio IC, and it'll be for the same reason. What happens is you end up with people who have got a power lead that has seen better days. Now here on my bench, I put it against that white piece of paper, is a power lead that has seen better days. So we've got the correct plug for the Cybernet. This is not come with this radio, it's just we've got half a fuse holder, we've got some insulating tape, and that's it. And what happens is there's no fuse in there. They should be fused at 3 amps. So what happens is get connected the wrong way around, positive to negative, negative to positive, and the protection diode then goes short circuit, and then it creates a short circuit, and this is what happens. Now if you put enough amps at it, the protection diode will disintegrate, and then there'll be no protection, and then you start having to replace chips and things. This is actually the test lead I use for 2-pin Cybernet type plugs, because I'm using of a regulated power supply which is set for 1.7 amps cutout. So looking at the audio chip, which is there, I can't see any sign of bulging. It quite clearly says Toshiba on it, so that will no doubt be fine. So the protection diode looks to me to be that. Yes, it's that there. So we've got the socket, we've got that blue capacitor, and the diode is just there between there and the coil. So I'm going to unsolder that and make sure I see what polarity it is when I take it out, and we'll take it from there. So it's also marked on the printed circuit which way around it is. So effectively the positive end is this one with the stripe. And we'll get the meter back out. And again we'll just prove the prods are showing continuity. And there we have a short circuit protection diode, which I will immediately, if I can find it, put it in the vertical filing cabinet. Oh, there it is. Gone. I will just go to the stores department and select a suitable diode, which will be 1 amp 50 volts. So don't worry about what number it is, which has come out. It's 1N4001 or any in that series, which are fine. That's a 1 amp 50 volt diode. So with a new diode in my hand, and the quickest one to find was 1N4007, which is a real overkill because it's 1000 volt rated. If I put this on my meter, which is set to diode test, we will have nothing in one direction. Swap the prods over and we should have something in the other direction, and that's about what you'd expect, 700 ohms. So we will fit that. So now, having put the diode in down there, and I've just cleaned the other side of the board with isopropyl alcohol to get rid of flux, we shouldn't have a short. No, we haven't. So we can now power the radio up. I'll go and get myself a microphone from stores. Right, so we'll get the microphone out. I buy 2 types in bulk, one wired Cybernet and the other wired Uniden, and everything else we just make up from ones which we buy with nothing connected. There's so little difference between the price of the ones with the plug and the ones, I think it's 45 pence difference. I can't even buy the plugs for 45 pence. So with that stubby little bit of wire that I was dangling around and showing you, I want to now plug this into our, here it is, into our regulated power supply, which is set for a 1.7 amp cutout. So we've now got that it successfully connected to the power supply, and the power supply is on, doing 13.6 volts, and no current is being drawn. I'm going to take the bold move and plug the test equipment into the aerial socket. And we will switch on. And it's on channel 1. So we'll select channel 20. Okay, I'll put camera 2 onto the test set, and then we can see together whether it transmits. Right, so let's go into transmit. And it does transmit. It is doing 3 watts. So we'll do a tune-up. That'll be the fault. That'll be why it's been discarded. And isn't that wonderful that it's come out of a skip and it hasn't been turned into mincemeat or whatever they do with them. Cybernet Beta 2000. Transformer 2. Transformer 3. Peak. That's 3. Yes, a bit low with this. I'll just go through that a few times and see if we can make any improvement. Okay, after doing that a few times, we've got it up to about 3.6 watts. As any radio transmitter drops off a bit in power as it warms up, so from cold it'll probably be 4 watts. So we'll just have a look at it having warmed it up dramatically. 3.8. Okay, let's look at low power. So we'll switch it to low power. It should be 400 milliwatts, and it's 3.8 watts. Oh, that's not low power. Low power's at the back. It's a Wally. Low power's doing about 50 milliwatts. The preset often gets dirty, which is at the back there. So we'll waggle that around. That tool doesn't fit. They're very small presets on this function. And there we have about 360 milliwatts. So that's the 3 watt scale. So we'll pop that back to full power. We'll look at the deviation. Switch the little oscillator on. Well, that's low, isn't it? Good grief, it's about 1.3. Let's try it with my voice. Wallow. No wonder they got rid of this set. Deviation is that one there. Wallow. 2.2 to 2.5. Just where we want it. Now the meter. It's swinging straight across all of them. So let's make sure it's only just going all across with all of them. And so the meter is the front of the two here. So into transmit. Oh, I can't adjust that out. Why is that? I'll just switch it to low power to make sure we've not got some strange malfunction. So we can adjust it on low power. So I'll turn it down to minimum so we know which way it is. Switch it to high, and that's what you get, the full set of lights. So we can't turn it down any more than that, but that is about where we want it. And we'll check its on frequency. So I'll just pop camera 3 on instead of camera 2. So we're looking for 27.79125. 79113. So it's dropped slightly, which is quite expected for something 38 years old. And if I can find the preset, it should be going to be one of these, is it? We put the tool between the wiring and hope. There we are, 2, 3, that'll do. Okay, so on to receive, plug the test set in. and we can hear the test set at S9. I'll turn the squelch down, which is this fiddly concentric thing, and it's receiving at 0.3 of a microvolt. So the first thing we're just going to do is put it back onto S9 and check the detector is set right, so we've got maximum recovered audio. If that's not done, it can sound garbled. So I will just put the camera onto the oscilloscope for you. Somebody did ask me how the oscilloscope's connected, and it's ever so easy. It's just across the speaker output. So the speaker output goes to the extension monitor speaker you can hear. It goes into the test set, and it goes into that oscilloscope, and it goes into the Cybernet meter. So there's nothing hard. So I've turned the bench lights off so we can see that. I'll just set the volume so we've got a better bit of amplitude. And now we want the detector coil, which according to my sheet is T12. T12 is that one. So we'll just check we've got maximum amplitude. A little fraction we've gained there, just a fraction. And whilst we've got that on at S9, we'll check that the meter is also reading S9 on the front. It's actually reading S1. That's an attenuator, an RF gain attenuator. I'm just checking it was in the right position. So the TX meter is reading too much, and the receive meter is reading too little. And that's the second one from the front, RV3. You know, I'm going to put that bench light back on. I can't see what I'm doing. And hopefully that will come up. Well, it's a bit of a lazy needle, you could say, but it means little anyway. I'd like that a bit higher, but that's how it is. Right, we'll run through the receiver, and the radio's come back on the hour. Okay, there we are. And what we're going to do is drop the attenuator on the signal generator. To about 4 decibels, and then we'll just go through the coils. We'll start at T5. Well, there's a bit of improvement. T7. Just drop the attenuator a bit. T6 isn't fitted in all radios. T8. There's a bit of improvement there. T9. T10. Minor bit of improvement there. Drop the attenuator a bit more, and I'll just go back to that first one and the second, because it can be interactive. No, I think that's great. I thought it was good before we started. So let's have a look. We've now got, for 12 decibels Cybernet, we've got 0.27 of a microvolt. For 10 decibel Cybernet, we've got 0.24 of a microvolt. So that's an excellent result. We were doing that expensive Albrecht splittable front set yesterday, and it did not work as well as this on receive. Not a lot in it, but it didn't work as well as this. So that leaves us now with Squelch. So we will drop off the signal generator and adjust that clumsy Squelch concentric knob for the threshold position. Switch the signal generator back on and see when it comes in. That was a bit tight, I would say. So I'm just going to check it at the other end. We'll put the squelch to maximum and see where it comes in now. It never comes in, ever. So that needs backing off. So that's really problematic. So there's the squelch control. So we'll drop that off. I've now got the signal generator on 1 millivolt. I'll back it off a bit further till it comes in. Back it off further at 300 millivolts. I think that's about where we're going to get it, which is about plus 10. So we'll now drop it to the other end of the... I've dropped the knob to nothing. Signal generator off. Threshold. And we'll now try again with the lowest sensitivity. So we're at 0.3 of a microvolt, 1 microvolt, 3 microvolts. You know, I still want to drop that off further. I'm going to put this on minimum sensitivity. We'll try that test again. So threshold, signal generator back on, 1 microvolt. So it's going off at 0.2 of a microvolt, and it's coming in. Oh, I'm reading this wrong. I'm sorry. I do apologise. It's coming in at 0.9 of a microvolt, and it's going off at 0.8 of a microvolt. So we'll now put the squelch again to the top position. I've spent more time setting the squelch than anything else. It's just above plus 9. So there we go. So we're set up. That's all working. So we'll pause the video. I'm not going to put the lids on. I'm going to put them through the company dishwasher. Okay, well 19's got its usual rubbish on. Quick flick round. It's quite a lot of foreign interference. Don't know what that is. So pop it on our favourite channel 31. Turn up the very annoying concentric squelch, which is a faff everybody says, and it's true. So nice set. Gave the case a very quick respray just because it was so rusted over, if you remember. I've not gone to a lot of trouble, but I did sand it down a little bit so it does look that bit better. So what we're not going to use the usual camcorder. We'll just do it on the CCTV system in here, and I'll ask Mr. Chippie to go to the car and just ask him to go to Scratchy Corner. It's not an on-the-air test as such, and I just want to hear what this radio now sounds like, especially if we can keep the power on it. Makes you wonder how many CB radios that are totally reusable end up in the skips, you know. And these were a nice set at the time. Tango 21, Mr. Chippie.
Roger, Tango 21, go ahead.
Just going to need to turn the tannoy system down because it's coming through over the scanner.
Still going to, yeah?
Roger. Tango 21, Mr. Chippie, how are you doing?
Yeah, roger that. Yeah, just going past Lancaster service station.
Roger. I just realised we're on the extension speaker into the test instrument, so it needs to be on its own speaker. I'll just talk to you again because I've just realised I was on the external speaker, and that's an unfair test over.
Yeah, roger that.
Well, that's more like you'd expect.
Right, we are square-wheeled at Ancaster Crossroads.
And of course it's loud and clear, and for the viewers that's about a mile away. Oh, Mr. Chippie, can you knock it up to 32 over?
Right, you there?
Yeah, Roger, on channel 32. Just when you don't want any foreign interference, we get it.
That's right. Right, we're just going over the top of the hill.
Okay, Roger Dodger. Yeah, he's just going to go to Scratchy Corner, which is about 2.5 miles away, the wrong side of a hill and right in a dip, hence we call it Scratchy Corner. It's so scratchy that even entertainment radios drop out.
Tango 21, Mr. Chippie, Scratchy Corner.
Oh, that's excellent. Loud and clear going around Scratchy Corner. So if you just like to loop round and return, that's where it will end. And when you come back round, talk to me again at Scratchy Corner and then the top of the hill, and we'll call it a day. That's over.
Roger that. It's going... can be very scratchy here. What is this?
Yes, I just had to drop the squelch a bit. I take it you're down by the church now, over.
Yeah, it's gone past the pub, the ploughing.
Roger. Yes, so it's worth a visit, the ploughing, when we're out of this lockdown.
Roger.
Church is worth a visit too. It's been there 1,000 years.
Passing the post office.
Yep, Scratchy Corner Post Office, which is where I'm sending everything out from at the moment. Better pop the squelch up a bit. It's more of that foreign interference.
Right, so we're back out the other end of the village at Scratchy Corner again.
Well, that's excellent. I did manage to get a few more ounces out of this receiver.
Right, we're back at the top of the hill.
Okay, thanks very much for the test. See you back at Tango Towers. That's excellent.
Roger.
Yeah, so we didn't need to do a proper test because we've done Cybernet 2000 before. It's nice to show a set working nicely that's come out of a skip. I'm very appreciative of that being sent to me. It's very kind of the person to do that and to stump up the post. What I'm just going to do, I can't do a base station thing because it's a different format, the camcorder, to what this is. So what I'll do, I'll put my realistic handheld on. That's the little TRC 1003. And we'll just put it somewhere near the microphones. Obviously, we're going to get some. Whoops! We're going to get some feedback. Testing 1 2 3 4 5 5 4 3 2 1. Testing 1 2 3. Gives you an idea that it's crystal clear. So there we are. I hope that's been an interesting repair and a diagnosis, and tuning it up so that it's spot on right through to hearing it working. Even though it was only 2.5 miles, at least he went to Scratchy Corner. So. Thank you to the person who kindly sent it me, and thank you for watching.